I'm now going to go after an example of how to prepare a solution of a known molarity. Here are the 4 key steps. Circle them and know them. First of all, first step is you need to calculate the mass required. Secondly, you're going to take weigh out that mass on your digital scale and balance, and we'll put it into a volumetric flask. Then we're going to add distilled water, circle distilled water, keyword, not just regular water, but distilled water, if we don't want other chemical reactions occurring. And also circle volumetric flask, that is the correct flask that we're going to actually use. We add distilled water that will swirl a little bit, and let the solute completely dissolve. And then we'll finish filling up the remainder up to the volumetric flask, which gives us a reading, and we can actually fill up the remainder with distilled water. Let me give you an example, a great example what to see on the test, and I'll go through this example in class. First of all, this is what I want. I want to prepare 500 milliliters of a 0.200 molarity potassium dichromate. So I always start out with my single amount, and I realize now in this situation my molarity will become a conversion factor. So my step one, I need to calculate the mass, where I realize I'm starting out with volume. So I'll start out with my 500 milliliters, but then I'm going to use my conversion factor molarity to get me from liters to moles. And so I realized, well, my 500 milliliters, I need to convert that to liters right away, so I just move the decimal place over 3 places, and it's 0.500 liters. Then I'll plug in my molarity. It is 0.200 moles of potassium dichromate per every liter. Or remember, you could put moles over liters, liters over moles. It does not matter. The only thing that determines that I'm going to set up my molarity this way is the fact that I want my liters to cancel out. But now I'm in moles, but I want to calculate the mass. So I need to get now from moles to mass. I do that by way of molar mass. And I get that from the periodic table. So I'll add up 2 potassium, 2 chromates, and then 7 oxygens. And I have here this situation, we have 294.2 grams per every mole. I multiply straight across, and I realize I need 29.4 grams of potassium dichromate. I'm now going to take this and we'll actually measure out this amount on a scale, and I'm going to add it into my volumetric flask. Into my volumetric flask, I'm going to then add distilled water, swirl it so it completely dissolves. Then I will finish adding up the water up to the mark on my volumetric flask. And I will show you the volumetric flask again in class and in our examples. But this is a great test question because not only will I have you do a calculation, I will then have you write this little bit that you see down at the bottom of the page explaining the steps you'd go through. And those are the steps at the very top, 1 through 4. So what you do, you weigh out 29.4 grams potassium dichromate, place it in a 500 milliliter volumetric flask, add some distilled water, swirl, fill distilled water to the 500 milliliter line on your volumetric flask.